So this is my potato pendulum. And we're gonna oscillate it. Some fun and learn about the scientific method. This is how it works. Alright. So we're gonna fix the length, right? And then hang it somewhere. Then give it a little bit of deflection and let go. And then we're gonna count the number of times it will oscillate. Like for example, if I leave it from here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So for 10 oscillations, we will count how much time it took. And then we will also record the length. For example, the length will be from the center of the potato to the place where you held it. So this is like about 24 inches, okay, which is, you can convert that into centimeter, 24-inch length. And we're going to do that for different lengths. For example, like this is 8 inch, right? Here is the night of the potato, pendulum. Come on, say hello. Night of the potato pendulum. So again, this is 8 inch, and then we're gonna deflect it by small angle and let go, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we will measure how long it took, okay? So next one, I'm going to do, so this time you're gonna help me, okay?
Okay.
So what's going to happen is that I have a stopwatch.
We're gonna count the millisecond.
Yes, we're gonna count the seconds, okay? So whenever I say go, you hit that play button, okay? And we will see how long it takes. All right, ready?
Yeah.
Let's just try. Go. Uh-oh, stop. Okay, reset. Go. Stop. Uh-oh, go. Stop. Go. Go. Stop. No, not reset immediately. You have to count the time. Go. Stop. Reset. Okay, you need to record the time like that. Okay. So on this notebook, you will take notes for how long it takes. All right, hold on. So this is your time for 10 oscillation, okay? And then this is the length here. So we are making a table where we have the length, okay? Currently in inch, we will convert that later, and the time for 10 oscillation in second, and then we will find the time for 1 oscillation later, okay? So that's how it works, okay? You ready?
Yep.
Okay, so the length of this pendulum, suppose in this case I have to measure the length of this pendulum, potato pendulum, from my center of this potato. So I'm recording this length. Let me say I'm gonna do 16 inch. Okay, 16 inch. Ready? So that's my support piece right here. 16 inch right here. All right. Are you ready?
Yep.
Go. Stop. Okay, I'm just checking. Reset. All right. So when I say 10, you stop. Okay, and don't reset.
Okay.
Stop. Whatever comes out the time, write down over here. Okay. Ready? Okay. We're gonna count down. Okay. 3, 2, 1, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Stop. Did you? Okay, that's 12.66 second. All right. So write down 12.66 second here. Since it took 12.66 second for 10 oscillation, it means it took 1.266 second for 1 oscillation. Okay. All right. So before I go into the details,
I would like to briefly discuss the scientific method with you so you can make your own decision about the data that you gather. And we will see how close we get in terms of our decision making. Did you know that grandfather clock did TikTok before it was cool? All right, what is scientific method? The scientific method is a framework basically where we define certain steps and follow a protocol to observe the world around us carefully and experiment, design the experiment or conduct the experiment to gather data. And the data helps us to refine our curiosity or our assumptions. Some people call it hypothesis about the world. We test the hypothesis constantly in our scientific endeavor. So if your mom told you not to touch the oven, you probably it's like, okay, can I test that hypothesis? Some of us did try that, right? And then, we gather the data. Sometimes the data or the experiment can be painful, right? So, so your hypothesis can either survive your test or it can fail. But on the light of that new data, the hypothesis is refined nonetheless. We will follow the scientific method for our experimentation, right? So the first question would be if we have the potato pendulum, for example, right? So this is my potato pendulum right here, right? For the given length of pendulum, do you think that the time period depends on the starting angle? That meaning that if I were to start it from here and then count it, right? Count the time period don't give it the push though, you just gently release it, right? Does the time period depend upon the initial angle? You start here versus here. Do you believe that the initial angle has any role to play in the case of the time period? Your hypothesis could be like a yes, the angle will play a role in determining the time period, right? You can take an educated guess. All right, you design the experiment, so gather the data, not that data, um, and then you think about the variables, like what are the variables that are involved in the experiment. For example, in the case of the experiment, the independent variable could be the length of the pendulum, right? Like it's your length could be like a meter, 2 meter, or 10 centimeter, right? The length. The angle could be another independent variable, like because you can totally control and then change that angle, right? So those are independent variable, and depending upon what variable you chose, the dependent variable is the one that's going to be appearing in your experiment. For example, if I were to change the length, the time period may be different, right? If I change the different length, the time period may be different. If I change the angle, what will happen to the time period? So the dependent variable is basically a function of the independent variable that you can control, that you can set. All right. Usually the independent variables are plotted on the x-axis and dependent variable are plotted on the y-axis whenever you are doing the analysis. And there are certain things called controlled variable, which is like in this case, you know that from the first activity, if you are inside Earth's gravitational field, then the acceleration due to gravity vertically downward is going to be the constant. The control variable should not change between the one set of experiment to the other, right? For example, if I was doing an experiment, right? If I were to do an experiment over here, then if I repeat it again later, the value of acceleration due to gravity should not change between that time, right? So that's the control variable. Keeping the acceleration due to gravity the same, that means we perform the experiment on the surface of the Earth in the same location for two set of experiments. What's going to happen? It's exciting. So we design the experiment here, right? So we will set up the experiment at a lower angle and then perform the experiment, and then we redo the experiment, right, for the same length find the time period. Let's call it T1. Another angle, perform the experiment. That would be T2, the time period taken for one oscillation. The things to do would be first predict, right? Do you think that the time period depends on the starting angle? Yes or no, right? And why? Why do you think that you chose whether it is yes or no? Because this is the prediction, right? This is the prediction. Is the share market going to collapse tomorrow? Yes or no, right? That's your prediction. And you can say why, right? You can think about what could make the share market completely, change tomorrow for better or worse. Is it going to rain tomorrow, right? Yes or no? There is 50% chance. Oh well, okay. So these are the questions that you can ask in scientific method. And then you design the experiment. First, set the pendulum at lower angle. Measure the time period basically by taking the measurement of the time for 10 oscillation. I think this one is going to be easier than the first experiment that you did with the coin drop. I saw that a lot of people had trouble stopping the clock. I think this one is easier because you can expect the 10 oscillation, which is going to be longer than the fraction of a second. So I have prepared an Excel spreadsheet for you. For example, here you can see that you have three cases: case 1, case 2, and case 3. This will be shared with you, by the way, right? And the length that you measure is given here. Always put the length in meter because that's the standard unit. If I measured it in inch, which happens to be the case because I have the inch tape around me, but you can always convert that into the centimeter and measure the time taken. For example, for 16 in my video, you saw that if I had the length of the pendulum to be 16 inches, for example, the length is, by the way, from the center of the potato to the top of the support, okay, center of that hanging mass to the top. So if that happens to be 16 inches, then you can convert that into centimeter and then find the time taken, right, for 10 oscillation. Okay, time taken, this is for 10 oscillation. You can basically divide the time taken by the number of oscillation to find the time period. Okay, and similarly you would do the same length, right? So same length, I can just drag it here now, right? Or I can make a copy, and then you this is for a first angle, right? It could be like a small, like a 5 degree, another could be 10 degree, right? So different angles, angle 1, angle 2, and this first angle, second angle doesn't have to be exactly same with this the other angle in the second and third case. Okay, so these are three still independent set of experiment. And once you have that, you can test your hypothesis, right? Again, the challenge for you is first formulate your hypothesis, conduct your experiment, repeat the experiment for 3 different lengths, each length with 2 angles, and you will be submitting on the Google form your time, your length, and then whether your hypothesis was supported or not. Hopefully it is simple enough, but insightful in terms of giving you the idea about the scientific method.